Good evening, sir.
Good evening, Manaswita. Good evening, Amma.
Good evening, sir.
Manaswita, are you listening to me?
Yes, sir.
Okay, good evening. ఇంకెవరైనా జాయిన్ అయ్యారా? ఒక్కదానివే కదా?
అవును సార్.
ఓకే. Deepika, good evening.
Good evening, sir.
Shall we wait or shall we start? Shivaji?
Start చేద్దాం సార్.
Shivaji.
Sir,
How are you? How are you, Shivaji?
yes, sir. Fine, sir.
Shall we start or shall we wait?
Sir, నేను కాల్ చేస్తా ఒక్క నిమిషం సార్.
Okay, okay, carry on.
ఓకే సార్.
దీపిక,
సార్
ఏంటి ఇన్ని రోజులు ఎక్కడ పోయినావు?
సార్ నెట్వర్క్ ప్రాబ్లమ్ సార్.
ఓకే, నో ప్రాబ్లం. ఇప్పుడు ఓకేనా?
నేను నెట్వర్క్ మార్చేసిన సార్.
ఓకే, గుడ్. మనస్విత అండ్ దీపిక,
సార్
నేను ఒక లింక్ పంపాను, మీరు అందులో జాయిన్ కండి. అది యూట్యూబ్ లైవ్.
ఓకే సార్.
చాట్ బాక్స్ లో చూసారా, దాన్ని క్లిక్ చేయండి సరిపోతుంది.
ఓకే సార్.
దాన్ని క్లిక్ చేసి
సార్ స్టార్ట్ చేయండి సార్.
చేయనా? ఓకే. శివాజీ, చాట్ బాక్స్ లో ఒక లింక్ ఉంది, చూసావా?
సార్.
కనిపిస్తుందా?
ఎస్ సార్. ఎస్ సార్.
దాన్ని క్లిక్ చేస్తే యూట్యూబ్ లైవ్ కి వెళ్తావు. దాన్ని క్లిక్ చేయి. ఓంకార్, ఆర్ యు దేర్?
సార్
ఓకే, స్టార్ట్ చేస్తానా?
ఓకే సార్.
ఈ యూట్యూబ్ లైవ్ లింక్ ఉంది, దాన్ని క్లిక్ చేయండి. ఓంకార్, చేసావా?
చేశాను సార్.
ఓంకార్,
చేశాను సార్.
ఓకే, ఒక్క నిమిషం యూట్యూబ్ లో చూస్తాను మిమ్మల్ని. ఓకే, ఓన్లీ 1 వాచింగ్ అని వస్తుంది. 2 వాచింగ్. ఓన్లీ 2 మెంబర్స్ ని చూపెడుతుంది, ఇంకా 4 మెంబర్స్ ఉన్నారు. Okay,
Yes, sir.
let us.
Chesan, sir.
Okay, let us start today's session. Today's session is continuation to previous session. That is 1 minute. See, in the previous class, what we are discussing about carboxylic acid and acid derivatives. In this, we are discussing about some acid derivatives. Actually, there are 4 acid derivatives are there. Among them, and there will be okay. There will be what I want to say is there will be 4 acid derivatives are there. One is the acid chlorides, another is the acid anhydrides, third one is the acid amides, and the fourth one is said to be the esters. In the previous class, we are discussed about the first 3 acid chlorides, acid anhydrides, and acid amides. Today we're going to start the other one is said to be the esters. Let us see what are these esters and how does they are prepared and what are the properties. Let us see this one, and again it was started with the amides only. Okay, this is going to be the esters. See, what are the esters? Esters is produced when carboxylic acid reacts with an alcohol. Means in general, acid react with a base to form salt and water. The similar reaction is carboxylic acid react with alcohol to form ester and water. Esters have sweet smell and are used as artificial flavoring substances in sweets, perfuming, syrups, pastry, etc. Esterification is analogous to neutralization of an acid with a base, but there is some similarity, only superficial. That is, esterification and neutralization both are looks same, but the similarity is only very little bit, that is superficial. Let us see what are the similarities. Esters are covalent compound, whereas the if you take these salts that is formed by the neutralization reaction, salts are ionic compounds. Esterification proceeds slowly, whereas salts formation is instantaneous. Esters are readily hydrolyzed. Salts of weak acid or base get hydrolyzed, whereas esters are neutral to litmus, whereas salts may be acidic, basic, or neutral in aqueous solution, depending on the nature of the salt formed. Esters are volatile and have pleasant odor. Volatile means easily get evaporated, whereas salts are non-volatile and have no odor. See, that is the similarities and differences here. Now let us go for the other one. How does the esters are prepared? There are different methods are there to prepare the esters. Let us discuss one by one. The first one is by refluxing silver salt of an acid with an alkyl halide in alcoholic solution. This method is very useful to prepare esters of tertiary alcohols. See, this is a silver acetate and this is going to be the ethyl iodide. See how does the reaction takes place? By looking at the equation, you can understood that by looking at the equation what happened? The silver and this iodide will be removed in the form of silver iodide. This is the case. Okay. Now this is going to be the ethyl acetate. This is going to be the ethyl group, and this is going to be the acetate group. That's why it is called as ethyl acetate. This method is very useful to prepare esters of tertiary alcohols. And another one, see, by the action of an acid chloride or acid anhydride on alcohol. These already we discussed in the properties of acid chloride and acid anhydride. When acid anhydride or acid chloride when treated with the alcohol, you will get the respective ester. See here acetic anhydride and treated with the ethyl alcohol, and it will give the ethyl acetate and acetic acid. Then the other one is methyl esters are conveniently prepared by treating an acid with diazomethane in ether solution. This method is mainly used for the preparation of methyl esters. What do you understand by the methyl esters? This is going to be the methyl group, and here this is going to be the ester because it is acetate. That's why it is called methyl acetate. And for the preparation of methyl acetate, and the reagent or reactant will be, the main is the diazomethane. This is very useful in the preparation of the methyl esters. Suppose if you take here acetic acid, you will get methyl ester. Suppose here propanoic acid, you will get methyl propanoate. Suppose if you use here butanoic acid, here you will get methyl butanoate. Here this method is mainly used for the preparation of the methyl esters. Then let us see the Tisch co-reaction. This is also one of the method for the preparation of the esters. What is Tisch co-reaction? When 2 moles of aldehydes are condensed in presence of aluminum ethoxide, the esters are formed. What is Tisch co-reaction? This is a condensation reaction between the aldehydes. And what is the catalyst is used here? The aluminum ethoxide is the catalyst. And this reaction is specially called as what is called Tisch co-reaction. See, this is the reaction. This is going to be one aldehyde, acetaldehyde molecule, and this is another acetaldehyde molecule. See what happened? The hydrogen is taken by here, and here one O is missing here. You have to remember here this O is missed here actually, and you have to write here one O here. Here one O is there, and therefore this is going to be the, what is that? Ethyl acetate is the compound. That means one hydrogen is transferred to here during the condensation, and this is going to be the oxygen, and here that will be during the condensation. And this method is specially called as Tisch co-reaction. Other one is esterification is okay. Now you have to remember that this is one of the very, very important method for our theory examination and also for entrance examination. Okay, and the previous method is meant for the mainly for the entrance examinations, whereas this method, whenever you are asked a question in theory examination, you write this answer. What is esterification? Explain with a suitable mechanism. Like that, you ask the question. Esterification is a reversible reaction. What is esterification? Esterification is nothing but carboxylic acid react with alcohol in presence of a small amount of acids or base also to form the ester is called esterification. That is, esterification is a nothing but carboxylic acid react with alcohol in presence of small amount of acid or a base to form ester, and water is called as the esterification reaction. Suppose if we take the acidic medium, here we use the 5 to 10% of concentrated sulfuric acid or dry HCl will be used as a catalyst. Here the carboxylic acid reacts with the alcohol. How does here? The OH of the carboxylic, okay, here the H plus of the carboxylic acid and okay, OH of the carboxylic acid and H of the what is called as the alcohol will be removed in the form of the water. This is what is ester, and this is called as the water. This double-sided arrow mark should be here. Now See, mechanism of the esterification is important for theory examination as well as the entrance examinations. Esterification is a reversible reaction, and to get good yield, forward reaction has to take place with a greater velocity. That means if you observe, I told you already, it is a reversible reaction. See, it is a reversible reaction. For the formation of the ester, the forward reaction must be occurred. And because of this reason, the forward reaction must be favored. And the reverse reaction must be hindered, means decreased. How does it will be decreased? By removing the water from here. If there is no water available here, the reverse reaction will be hindered. That means it is slowed down. Therefore, more amount of the ester will be formed. That means for the esterification reaction, the forward reaction must be done with a greater velocity. For that case, water which is formed in this reaction is removed as soon as it is formed by using dry HCl or concentrated sulfuric acid, or sometimes we can use the heated metallic oxide like thorium oxide also. See the mechanism. This is in presence of acidic medium. This is a carboxylic acid. Suppose I took here example is acetic acid. And acetic acid, the first step is said to be the protonation step. How does it is protonated? Here you know that the carbon oxygen, the oxygen is more electronegative. The pi bonded electrons are more attracted towards the oxygen. And that's why what happens, it is some partial electronegative and it is partial electropositive. That's why the proton will go and add here. That means the oxygen will take this proton, and here you will get the protonated oxygen. And because of the reason here, what happened? The carbocation is generated. That is carbon having the positive charge. In this case, you know that it is ethyl alcohol. It is looks like water. Suppose if it is removed and placed hydrogen, that is going to be the water. That is, it is a product of nothing but the water, similar to the water. In the water, you know that there is a 2 lone pair of electrons on the oxygen. The same you can observe in alcohols also. So whenever a lone pair of electron, it acts as the electron pair donor, or it is acts as a nucleophile. It seeks the nucleus, it seeks the positive charge. And that whenever it attacks, this first step is called as a protonation step. This is called protonation step. This is called as a nucleophilic attack. The second step is called a nucleophilic attack. And it is attacked on the nucleophilic center, so that you will get this a product that is an intermediate, where you can observe that there is a positive charge on the oxygen. Whenever a positive charge on the oxygen, it is always less stable. Immediately loses a proton. This is the next step is said to be the loss of proton. The third step is said to be the loss of proton. And then you will get another intermediate. And you can observe that there is a single carbon containing 2 OH groups. You remember this. Whenever a single carbon having more than 1 OH group, it is always unstable. It tends to lose a water molecule and converts into a stable one. That's why here also there is more than 1 OH group is there. That's why it is unstable and loses a water molecule in this way. Here this bond is shifted between the carbon and oxygen. Simultaneously the OH, this OH and this H will be removed. That is here the last step we can say loss of water. The last step is say loss of water molecule takes place, and you will get the compound is said to be the ester compound. This is what is a mechanism of esterification, and this is very, very important for theory examination as well as entrance also. But in the theory, they will ask the question like this: what is esterification? Explain with a suitable mechanism. In that question, for that question, you have to write all these steps. First, you have to write what is esterification. What is esterification? Carboxylic acid react with alcohols in presence of acid or base to form salt and water is called esterification. RCOOH plus ROH gives ester plus water. You have to write. After that, if you are asked a mechanism, you have to write how many steps here. One is said to be the protonation step. Here, first step is said to be the protonation step. Second step is said to be the nucleophilic attack. Third step is loss of proton. Fourth step is said to be the loss of water. These 4 steps you have to write for getting the good marks. Now let us see. Other one is what happened in the in case of esterification. Suppose you are given a different alcohols. The rate of esterification of the alcohols is in this order. That is, primary alcohols react faster than the secondary alcohols. They react faster than the tertiary alcohols. Means, suppose this is for the entrance examination. For a given with a given alcohol, what is the for a given carboxylic acid, what is the rate of reactivity of the alcohol in the esterification? In such cases, you remember this order. Primary alcohols reacts faster than the secondary alcohols, and they react faster than the tertiary alcohols. Now, let us take other one. In the case of the, what I mean to say, ketones react with alcohol to produce what is called as the acetic acid esters. This is going to be the, even this is one more method of the preparation. And here this is the ketene we have discussed in the previous classes. When a ketene is treated with alcohol, here also you will get the ester is the compound. Then other one is the carboxylic acids react with alkene in the presence of boron trifluoride. See, this is, this is ethylene. And when ethylene is treated with the acetic acid, you will get ethyl acetate. Means simply a proton is transferred. And that is, that here, I will tell you what happened here. You know that in ethylene, there will be carbon-carbon double bond is there, isn't it? Carbon-carbon double bond. Here it is CH2. And here also it is CH2. What happens? In this carbon-carbon double bond, one of the pi bond will be broken. And it results in the formation of a new sigma bonds here and here. For this, one hydrogen is added here. That's why it is going to be the C2H5. And this oxygen is added here so that you will get the ethyl acetate. And this reaction is carried in presence of boron trifluoride. Now let us see, other one is aromatic substituted acids react with alcohol to form the ester. Similarly, substituted phenols react with the acetic anhydride to give the ester. See, this is going to be the aromatic acid chloride, orthobromobenzyl chloride, COCl. This is going to be the COCl. And when treated with the ethyl alcohol, you will get ethyl orthobromobenzoate because it's the ortho position, bromine is there. That's why it is called ethyl orthobromobenzoate. Now let us see one more is here. This is going to be the para-nitrophenol. Here it is acid chloride. Here it is phenol. When para-nitrophenol, when treated with the acetic anhydride, you will get para-nitro. What is this? Acetate. Here phenyl acetate. This is going to be a phenyl, para-nitrophenyl, and this is going to be the acetate group. See why I am telling all these reactions are. All these are useful for your entrance examination. But I told you one thing for your theory examination. With the mechanism I explained that you can write that that reaction itself enough for your theory examination. Let us see the properties of the esters. Esters are colorless, neutral liquids. They are neither acidic nor basic. They are maybe liquids or solids with a characteristic pleasant smell. That is, straight chain esters have higher boiling point than branched chain isopers. Many of the esters are good solvent. I want to tell you one important point. Suppose you get a question about the boiling point and melting point. Whenever you get a question about boiling point and melting point, for a given compound, you remember straight chain. That means straight. That is straight chain. I am writing only one. Straight chain will have always higher boiling point. You remember, straight chain will have the higher boiling point, always higher melting point. Straight chains means what? Suppose here this is the case: 1 carbon, 2 carbon, 3 carbon, and 4 carbon. Let us take. This is going to be a straight chain with the same number of carbons. Suppose you write its isomer, other isomer like this. There are 4 carbons, but here it is branches there. When you compare to this is the normal butane, this is said to be the isobutane. The normal butane, that is going to be the straight chain, will be always having the higher boiling point. This point you have to remember when compared to this one. ఏ కాంపౌండ్ ఇచ్చినా మీరు గుర్తు పెట్టుకోవాల్సింది, ఒక ఐసోమర్ ఇచ్చాడు అనుకోండి, దాంట్లో స్ట్రైట్ చైన్ కనుక ఉన్నట్లయితే that will have the more boiling point when compared to the branched chain. This point you have to remember. This is applicable for all types of compounds, not only alkanes. Any compound you take, the straight chain isomer is always having higher boiling point or melting point when compared to the its isomer. And here another important point. Why? Because in the straight chain, more is the surface area. Here the surface area is more when compared to the branch. More is the surface area, more will be the boiling point. This point you have to remember. Now let us go for the other. Esters can split by different substances easily, and they can be undergone splitting by ammonia. That process is called ammonolysis. When it is splitting by alcohol, it is called alcoholysis. When it is splitting by acids, it is called acidolysis. When it is splitting by alkali, it is called saponification. Suppose when it is splitting by water, then that is called as hydrolysis. Means we have to remember that what is hydrolysis? Reaction with water. What is ammonolysis? Reaction with ammonia. What is alcoholysis? Reaction with alcohol. What is acidolysis? Reaction with acids. What is saponification? This is a reaction with the alkali. That point you remember. Now let us see this one. First, let us see reaction with PCl5, phosphorus pentachloride. Whenever it is treated with the phosphorus pentachloride, what happens? The product is acetyl chloride. Means here 1 chlorine is taken by the COCl and another chlorine is taken by this one, and the byproduct, what is the byproduct here? 2 chlorines are removed, therefore the byproduct is POCl3. And this is going to be a byproduct. I already told you, while learning organic chemistry, what you have to remember? RRP. What is RRP? A reactant, reagent, and product. Therefore, here this is a byproduct. That's why it is not mentioned. It is not important. The reactant is here ethyl acetate. The reagent is phosphorus pentachloride. What is the product? Acetyl chloride is the product, and ethyl chloride is the product. You have to remember. In the case of what I meant to say, in the case of organic chemistry, you have to remember RRP: reactant, reagent, and product. Now let us see reduction. Esters can be reduced to alcohol. The reducing agent can be used either sodium plus ethanol. That means sodium in ethanol. You remember that is not sodium plus. Here it is going to be sodium and ethanol. And it is lithium aluminum hydride and hydrogen under pressure at 300 atmosphere. Means all these will supply nascent hydrogen. They supply nascent hydrogen. And here what happens, you see, ethyl alcohol I wrote 2 times. Why? Because to understood 2 times. Why here? This is converts into the ethyl alcohol, and this is converts into the another molecule of ethyl alcohol. Suppose here R is there, na? Instead of ethyl, you remember here, instead of ethyl, there will be R will be there. And in this way, the esters can be reduced to alcohol by using either sodium in ethanol or lithium aluminum hydride or hydrogen under very, very high pressure. Next is going to be the Ammonolysis. I told you what is ammonolysis. Ammonolysis is nothing but reaction with ammonia, where ammonia get split into the H plus and NH2 minus. Here, this is going to be the ester. This is going to be the ammonia. Here, ammonia gets split into two components. One is said to be the, this is going to be the NH2 minus, and this is going to be the H plus, like H2O. Then how does the H2O will split? H plus OH minus. Similar to that, NH3 will split into H plus and NH2 minus. What happens? This NH2 will add to the, what happens? To the one component, because there are two similar, and H plus will add to the here. Therefore, what happens? You will get ethylamine, and other one is said to be the ethyl alcohol. Now, what is the mechanism of the ammonolysis? See here, what is the mechanism? In this ethyl acetate, you know that carbon-oxygen bond is polar, and here the pi bonded electrons are more attracted towards the oxygen. And here ammonia acts as what I meant to say nucleophile. That is, there is a lone pair of electron is there, it attacks on the carbonyl carbon. So that you will get an intermediate is here, where nitrogen having the positive charge. Now here it is a loss of H plus ion, and similarly loss of ethoxide ion takes place. And here what happens? The loss of H plus ion is taken by the what? This ethoxide ion, and this ethoxide ion converts into the ethyl alcohol, that is C2H5OH. And here what happens? This NH2 group, okay, this is converts into the, and okay, previous one is this going to be wrong actually. Here you should get not oxygen. Here it is not oxygen by printing mistake, and here it is oxygen here. This is going to be the amide. You will get the amide is the product, not amide. The amide is a product will be formed here. Here acetamide and ethyl alcohol is formed. Now let us see another reaction. Alcoholysis. What is alcoholysis? Reaction with alcohol is called alcoholysis. In the alcoholysis, the alcohol will split into the, what I meant to say, here the alcohols will split into the, you know that this is going to be the ethoxide ion. You will get, this is going to be the ethoxide ion minus, and here this H is going to be the plus during the course of the reaction. Therefore, ethyl acetate, that is here it is butyl acetate, because it is a C4H9, it is a butyl acetate. Here it is a butyl acetate. When treated with this ethyl alcohol, you will get ethyl acetate. Can you identify what happened in this reaction? This simply, the alcohol part in the ester, that is C4H9, is replaced by C2H5. This is butyl acetate. When treated with the ethyl alcohol, it will be it will form the ethyl acetate. That means simply when it is treated with the alcohol part is replaced in the ester. Now let us see acidolysis. Acidolysis is nothing but reaction with water. The residue of ester can be replaced by another acid residue. Means here what happened? Now we are treating with this an acid. Therefore, in the acid part, there will be here, this is going to be the, what is said to be the methyl group is there, and this methyl group is replaced by C4H9. Isn't it? This is a valeric acid. 5-carbon carboxylic acid is called valeric acid. Therefore, the methyl group is replaced by butyl group. Therefore, we get, this is ethyl, this is pantanoic acid. Therefore, ethyl pantanoic acid or ethyl valerate is the compound. Then you will get the ethyl alcohol is a normal one. Okay, this is also wrong. Print mistake here. See, where is my cursor? Okay, here also this is not ethyl alcohol. Simply here the CH3 will be replaced by this one. Therefore, here you will get CH3COOH. You will get here acid is the CH3COOH is the byproduct, not this one. Now let us see the other one is with Grignard reagent. How does the esters react with the Grignard reagent? With Grignard reagent, the formic ester means ester formed with a formic acid reacts with the Grignard reagent to give product which on hydrolysis gives the aldehyde. See, this is going to be the ethyl formate. This is the ethyl one. This is the formate one. Methyl magnesium iodide when treated with this one, you remember whenever a carbonyl carbon present in the reactant treated with the Grignard reagent, the MgI always go and add on the oxygen, you have to remember. And this methyl group will add on the what? Carbonyl carbon. This is the case here. During the reaction, during the hydrolysis, this OMgI is changed to OH. This is going to be the alcohol. This is the here. This is going to be the OH, and here this is what happened. This is aldehyde is formed. Another one is the ethyl alcohol is formed. This will be, see, this will be removed in presence of water, and this converts into the ethyl alcohol, and this converts into the acetaldehyde. Now let us see, that is with the pharma, that is ethyl formate. This is, let us take another example, ethyl acetate. Similarly here what happened? The OMgA is added on the oxygen, methyl group is added on the carbon. See here, it is added on the carbon. During the hydrolysis, what happened? This OMgA is MgOHI, and this will be converted into the ethyl alcohol, and the remaining part that is going to be the converts into the what happened? A ketone, that is acetone is formed. Now see, this is other one is with amides, sodamide or lithiumide. When an ester is treated with the sodamide and it is dissolved in liquid ammonia, condensation takes place together with the formation of an acid amide. See here what happened, you can understood. Ethyl acetate when treated with the sodamide, what you got? The compound is the acetamide. This is going to be the compound here. Here, this is going to be the CH3CO. It will take the NH2 and it is formed in the form of acetamide. And this Na will be taken by here, so that you will get sodium ethoxide is the compound. With amides, the mechanism, if you observe, this is going to be the ethyl acetate, sodamide. First, what happened here? One of the proton will be lost because here alpha carbon is there, alpha hydrogens are there. This is acidic in nature. One hydrogen is removed from here, and then the NH2 will be converts into the NH3. Here I already wrote you here. Here already I wrote you. And this is the minus, and this is going to be the plus. Now in the second step, what happens with another ester? This is going to be the another ester. This carbanion adds on the carbonyl carbon, and you will get an intermediate is here. Okay, and this intermediate undergoes some changes by loss of ethoxide, and finally you will get the compound is ethyl acetoacetate. This is what is called as the condensation product. Now hydrolysis. What is hydrolysis? A reaction with the water. Esters hydrolyzed by acids or alkalis to give alcohols and acids. If alkali is used, the alkali salt of the acid forms. Alkali salts of higher fatty acids are soaps. So alkali hydrolysis of esters is called saponification. And I think you know that about the saponification you are learning from the 10th class onwards. Saponification is used for the preparation of the soaps. Saponification is more rapid than the acid hydrolysis. Hydrolysis of an ester is a reversible reaction here. This is going to be the general hydrolysis reaction with water. You'll get the carboxylic acid and ethyl alcohol. Suppose when you use any base like sodium hydroxide, you will get here sodium salt of the carboxylic acid. Now let us see the mechanism. Here this is very, very important for the theory examination. What they will ask, what is ester hydrolysis? Explain with a suitable example. This Question will be there, and it was asked many times in the examination. In this topic, you have to, for the theory examination, you have to learn two things. One is, what is esterification? Explain with a suitable mechanism. Yes, what is your doubt, sir? We have Telugu class. Okay, within 5 minutes, I will close because this is at the end. Okay, hydrolysis. See, you have to learn two things. One is said to be the hydrolysis. What is esterification? Explain with a suitable mechanism. Another is, what is ester hydrolysis? Explain with a suitable mechanism. This is the last one. I'll close here. And here in this mechanism, ester hydrolysis in presence of acidic medium. First is the protonation step. The oxygen is protonated, a carbocation is formed, and for this attacking of the nucleophile attack, and water is attacked on the carbonyl carbon, and here the proton transfer takes place here, and finally you will get oxygen will get the positive charge, it is unstable and loses ethyl alcohol. This will be lost, and this in this step the ethyl alcohol will be lost. And another one, I told you already that whenever two OH groups are present on the same carbon, they loses water molecule. Finally, you will get the carboxylic acid. In this way, the ester hydrolysis with acid catalyzed mechanism you have to learn. And another one, you can say that one is going to be this is the base catalyzed. In case of the base catalyzed, the hydroxide ion is added to the carbon. When acid hydrolysis the H plus ion is added to the oxygen. Therefore, here the OH is added to the carbon. You will get this as an intermediate step, and the OH is added here. Then there is alkoxide rearrangement takes place, and alkoxide ion is removed in the second step, and you will get the carboxylic acid. But alkoxide is a strong base, therefore it abstracts the proton. Finally, you will get carboxylate ion and alcohol. This carboxylate ion will form with the sodium or potassium salts. Okay, this is what is said to be the ester hydrolysis. Okay, and this chapter, in this we discussed about the acids and esters. Okay, thank you for listening. We will close our session is here. Then tomorrow we'll take another lesson, another topic to discuss. Thank you for watching. See you in the next class.